In this video, we're going to talk about the number e. Now, you've probably heard of the number pi, right? Pi is about 3.14. Actually, it's a decimal expansion that keeps going on and on and on forever. But the number e is also an important constant in math. In fact, pi and e are probably the two most important constants in all of mathematics. And e is about 2.718. Okay, and again, it has a decimal expansion that continues on and on forever. But what do these numbers mean? Now pi, of course, the meaning of the word pi is if you take a circle, of course, every circle will have a center, so let's draw the center. And if we draw a diameter, so that just means a line that goes straight from one side of the circle to the other side that goes through the center. Okay, now when we speak of the diameter, we're talking about the length of a diameter. But when we say a diameter, we just mean any line that goes from one side of the circle through the center to the other side of the circle. Okay, now the question is, if we had a piece of string that was the length of this diameter, how many of those strings would it take to make it all the way around the circle? So notice if we took this piece of string that had this length and we started right here and we tried to wrap it around, we'd probably get to maybe, I don't know, about right here, do you think? Okay, and then if we took another one of those strings, we could start it there and maybe wrap it until we got to about, I don't know, maybe about right here. Okay, that would be 2. And then we could try a third one. And do you think the third one would make it there? No, not quite. 3 of them wouldn't quite do it. Okay, in fact, you need 3.141592 of them. Right, really you need pi of those diameters. Okay, so if you have a circle, pi times the diameter, that's equal to the circumference, right? Pi times the diameter. If you have pi of these diameters, that will get you all the way around the circle. Or another way of saying it is that pi is equal to the circumference divided by the diameter. And by the way, that ratio of circumference over diameter will always be the same no matter how big the circle is or how small it is. Okay, and that ratio is what we call pi. Okay, so what's this number e all about? Okay, well, this is a little bit trickier to kind of understand, but it's still not too bad. Okay, what is the meaning or the definition of this number e? Okay, well, let's consider the expression 1 plus 1 over n to the nth power for large values of n. Now, you might wonder, why are we doing this? Well, we'll see in a second here. Let's pick big values of n and plug it in. So, for example, if we plugged in 10 for n, we would get 1 plus 1 over 10 to the 10th power. Now, 1 over 10, 1/10, that's like 0.1. So 1 plus 0.1, that would be 1.1. So what we have is 1.1 to the 10th power. That means multiply 1.1 times 1.1 times 1.1, with a total of 10 factors there. Now, what is that? Well, notice every time you multiply a number by 1, it stays the same, right? If you multiplied 7 times 1, right, then you would still end up with 7, right? But if you multiply something by 1.1, it gets a little bit bigger, right? So instead of having 7, you'd have 7.7. So each time you multiply a number by 1.1, it gets a little bit bigger. So the first time we multiply this initial 1.1 by 1.1, it's going to be a little bit bigger than 1.1. Then we multiply by 1.1 again, it's going to be even a little bit bigger than that. We're going to keep doing that. We do it each time you multiply by 1.1, it gets a little bit bigger, but we do it, 10 times, with a total of 10 factors. Now, what do we end up getting? Well, let's get out our calculator here. If we actually typed in, turn it on here, 1.1 raised to the 10th power, what do we get? We get 2.59374. Okay, 2.59374. Okay, and it keeps going on and on. Okay, now let's try it with a little bit bigger n. Let's try it with n equals 100. Okay, we get 1 plus 1 over 100 to the 100th power. Now again, 1/100th is like 0.01, so we're really multiplying 1.01 to the 100th power. So we're going to multiply 1.01 times 1.01 times 1.01, do it 100 times. Now each time you multiply a number by 1.01, it gets a tiny bit bigger. Okay, but we're doing that 100 times. Okay, we have a total of 100 factors. So what do we end up getting? Well, let's try this in our calculator again here. Let's do 1.01. Okay, 1.01 raised to the 100th power. Okay, and notice what we get, 2.7048. Okay, we get 2.7 let's see, what was it again? 2.704813. 481, etc. Okay, now if you plugged in 1,000, what would you get? Well, let me not do it on there. If you plug in 1.001 raised to the 1,000th power, what you end up getting is, let's see here, you get 2.71692, etc. Okay, notice each time you multiply by 1.001, it gets a tiny bit bigger, but you're doing it a lot of times, right? You have 1,000 factors here. And notice you get 2.716. If you did this 100 or 10,000 times or 100,000 times or a million times, it's going to keep getting closer and closer to this number right here, and that's the number that we call E. Okay, now according to, if you go on and take calculus, you would say that E is really the limit as n approaches infinity of this expression. Okay, that's the way we define the number E. Now, this number E has all kinds of uses in engineering and physics. In particular, use to us will be its use when we're talking about compound interest or continuously compounded interest, more specifically. So you might wonder, what is the point of this number? Well, there's a lot of uses of it. It's just hard to see it hard to understand it when you first see the number.